Understanding large language models, LLMs evolution, current state, and future. Introduction. Large language models, LLMs, have transformed how machines interact with human language. These sophisticated models have been at the forefront of advancements in natural language processing, NLP, enabling machines to understand, generate, and manipulate human language in meaningful ways. Understanding their evolution, current capabilities, and future directions is essential to appreciating their applications and implications in various sectors. Evolution of LLMs. The journey of language models began with modest statistical models, which laid the groundwork for understanding linguistic patterns. The evolution can be broadly categorized into several key stages. 1. N-gram models. These were the early statistical approaches relying on fixed n-word sequences to predict the next word. Despite their simplicity, they laid the foundation for more complex modeling. 2. Word embeddings. The introduction of Word2Vec in 2013 marked a shift towards vector representation of words, capturing semantic relationships. This was further improved by GloVe and fast text, which considered contextual spelling variations. 3. Recurrent neural networks, RNNs, and long short-term memory, LSTM. These models allowed for better sequential data handling, overcoming the limitations of fixed-size contexts, but struggled with long-range dependencies due to issues like vanishing gradients. 4. Transformers, introduced by Vaswani et al. In 2017, the transformer model revolutionized language modeling by using self-attention mechanisms, allowing for parallel processing of data and capturing long-range dependencies effectively. 5. BERT, bidirectional encoder representations from transformers. BERT's bidirectional approach in 2019 advanced context understanding, outperforming many previous models in various NLP tasks. 6. GPT, generative pre-trained transformer. OpenAI's GPT series further pushed LLMs into the spotlight, with each iteration, GPT-2, GPT-3, exhibiting remarkable abilities in text generation, comprehension, and creativity. Current state of LLMs. LLMs today are characterized by their immense scale, both in parameters and data. Models like GPT-3 by OpenAI, with 175 billion parameters, showcase the scale and depth of modern-day LLMs. These models are capable of text generation, producing human-like text, articles, or creative content across genres. Question answering, understanding and responding to queries with coherent and contextually relevant answers. Translation and summarization, real-time multilingual translation and concise summarization of vast texts. Sentiment analysis, identifying sentiment and emotions in text, aiding in customer feedback or social media monitoring. Open versus closed LLMs. Open LLMs refer to models that are publicly available for use, modification, and further research. Examples include GPT-3. Though primarily accessible via an API, elements of OpenAI's practices promote collaborative research. BERT, released by Google, it is open source and has inspired numerous research papers and applications. Closed LLMs are proprietary and accessible primarily through services or restricted partnerships. These include models developed by corporations for specific proprietary use cases, often focusing on maintaining competitive advantages or adhering to stringent security protocols. Advantages and disadvantages. Advantages. Versatility. LLMs excel across diverse applications, from creative writing to coding assistance, thus broadening automation capabilities in numerous sectors. Efficiency. Once trained, these models can perform a wide array of tasks quickly without task-specific retraining. Disadvantages. Resource-intensive, training and deploying LLMs require significant computational resources and energy. Bias and ethics. They inherit biases present in data, leading to potential ethical concerns around fairness and discrimination. Interpretability. The complexity and size of LLMs make it challenging to understand their decision-making process fully. Future of LLMs. The future of LLMs is likely to revolve around more efficient and interpretable models. Innovations might include compression techniques. Developing methods to reduce model sizes while maintaining performance will make LLMs more accessible. Continued learning. Integrating continual learning to adapt dynamically to new information or tasks without retraining. Ethical frameworks establishing standardized practices to address bias, privacy, and security concerns effectively. Domain-specific applications tailoring models not just on scale but for particular industry needs, enhancing efficiency and relevance. Conclusion. Large language models are at the forefront of artificial intelligence, redefining the boundaries of what machines can achieve with human language. As research progresses, addressing their challenges while capitalizing on their potential will be pivotal in shaping the digital future, democratizing information and capabilities across societies.